Hi, Assalamualaikum. My name is Munir, and now in this video we're going to talk about the application of differentiation, where we're going to talk about applied maximum and minimum. So let's get started, shall we? Alright. For the first part of this video, we're going to learn about what is the application of differentiation. So I'm going to ask you viewers to open your ears wide so that you can get maximum understanding of what we're going to talk about of this topic. Ready? Then let's begin. What is application of differentiation? Well, application of differentiation involves using the concepts and techniques of differentiation to solve practical problems in various fields such as physics, engineering, economics, biology, and more. That is the the application of differentiation that we're going to learn about in this video further in the video, right? So make sure to stay tuned to this video. Right, in this topic there is something that is called related rates. Now, what is the related rates? Well, related rates is problems involving finding the rate at which one quantity changes in relation to another quantity that is also changing over time. So, to say in simpler terms, it's about two problems that is changing at over time, in the same time, at the same pace. uh, so like if this one is going up, then this one is going down, something like that. So to understand more, stay tuned. So because we're going to talk about it more deeper and deeper, so stay tuned. So now you know why we use related rates, right? But you're still not convinced, isn't it? Right? Well, I'm going to give you some reasons why we use related rates, right? As shown in the slides, the reason why we use related rates are modeling dynamic systems, optimization and control, understanding relationships between variables, and also predicting future changes. Right. Here are These are the list of the reasons we use related rates for to solve problems. Right.
So, what is applied at maximum and minimum problems? So, the first one is the process of finding maximum or minimum values is called optimization. Second one is many application problems in calculus involve function to find maximum and minimum values. Okay, here are the reasons why we use it. So the first one is in real life, it's usually used to maximize the profit in a company or minimize the cost to make a particular object. While in calculus, it's to calculate the highest and the lowest point of the curve in a graph or to know its turning point. Okay, why did we have to learn apply maximum and minimum problems? So first thing first, is to increase understanding about applications of differentiations. Second one is to understand apply maximum and minimum problems. And third one is to be able to solve the equations by using the suitable formula. So for the problem statement example is the radius of the base of a right circular cone is decreasing at the rate of 4 cm per minute and the height is increasing at the rate of 6 cm per minute. At what rate is the volume changing when the height is 12 cm and the radius is 6 cm? Okay, to solve these problems, first thing first, we must to know first what the method that we can use. So there are one method that we use, which is implicit differential methods. So the first step is we must to write formula for volume of the cone. And what is the formula for volume of the cone? So the formula is V equal to 1 over 3 pi square h. Okay, the second step is identifying two things, which is the first one is the given informations. So the informations that given is in this questions is the radius is decreasing at the rate of 4 cm per minute. So we have to write it as dr over dt equal to negative 4 cm per minute, which is why we put negative at the 4, because at the question stated that decreasing. So that's why we have to put negative. And what's the meaning of dr over dt? The meaning is the first derivative of r with respect with t, and it's also show the changes of r with time. And the second information that given is the height is increasing at the rate of 6 cm per minute, which is we have to write as dh over dt equal to 6 cm per minute. Okay, next, the second one that we have to identify is the unknown. At what rate is the volume changing when the height is 12 cm and the radius is 6 cm? So we write it as dv over dt equal to, we don't know, so we just put the question mark. And when height equal to 12 cm, radius equal to 6 cm. So the third step is differentiate the formula. So for this step, we use product rule as shown in the slide. Okay, after the differentiation step is completed, now we have to move to the next step, which is assign the value for radius and height. So for radius, the value is 12, and height, the value is 6. So we just assign it inside the solutions. Okay, next step is assign the value for the rate. Okay, when we assign dr over dt, we get negative 4 centimeter per minute. And then when we assign dh over dt, we get the answer is 6. And then we just multiply it and we get negative 576 plus with 216. Okay, last step is solve to get the final answer. So from the solutions before, we get negative 360 inside the bracket. Then from that, we just divide it with 3 and multiply with pi, and then we get the final answer is negative 120 pi. So as conclusions for the example questions, thus if we know the variables are related and how fast one of them is changing, then we can figure it out how fast the other one is changing.
A rectangular garden of 375 meter will be fenced. The fence price of the long sides are 3 ringgit per meter, while the broad sides are 5 ringgit per meter. Let X represents the long sides of the garden and Y represents the broad sides of the garden. For question A, show that the cost C of the materials is given by C equals to 2,250 over Y plus 10Y. For question B, find the values of X and Y that will minimize the cost of the material. And lastly, for question C, find the minimum cost of the rectangular asked to show that C equals to 2,250 over Y plus 10Y. Firstly, cost C equals to 3 ringgit times 2x plus 5 ringgit times 2y. C equals to 6x plus 10y. Next, we have to make an equation for the area of the rectangular garden. The area of the rectangular garden is changed into variables x, y. The area of the garden is already given in the question as 375. Therefore, the question is xy equals to 375. Next, we have to make x as the subject, which will turn the equation into x. equals to 375 divided by y. Now, we can substitute x into the cost equation that has been found above as c equals to 6x plus 10y.
Okay, now we go to question B. Find the value of x and y that will minimize the cost of the material. First, c equal to 2250 over y plus 10y. dc over dy equal to negative 2250 over y power of 2 plus 10. Let dc over dy equal to 0. Negative 2250 y power of 2 plus 10 equal to 0. Okay, then 2250 over y power of 2 equal to 10. Then 10 y power of 2 equal to 2250. Okay, last y power of 2 equal to 225 y power of 2. Then we can get y equal to 15. Okay, that's the answer. Okay, now we go to second derivative test. First, d power of 2 c over dy power of 2 equal 4500 y power of negative 3 equal 4500 over y power of 3. Okay, next d power of 2 c over dy power of 2 equal 4500 over 15 power of 3 equal 4 over 3 less than 0. Okay, so y equal to 15 is a minimum value. So when y equal to 15, x equal to 375 over 15. So we can minimize that value equal to 25. Okay, now we go to question C. Hence, find the minimum cost of the rectangular garden. First, we create minimum cost C equal to 225015 plus 10 multiply 15. Then C fraction 2250 multiply 15 plus 10 multiply 15. Then C equal to 152250 plus 10 multiply 15. Okay, for the answer, we can see that RM 300s equal RM 300s and equal RM 300s. Okay, it's the same answer for that C, like I say before.
So, as conclusions, by applying differentiation method into these solutions and problems, what we can conclude is that the applications of differentiation can be used to: first one, define a value of a volume. The second one is solve any other kind of problems. And the third one is solve problems related to value of volume.